Vaporization is a process in which a liquid is changed into gas. When the kinetic energy of liquid molecules increases, the molecules will move faster. There is more molecules possess enough kinetic energy to overcome the intermolecular forces, thus the molecules escape as vapor in the gas phase. These are water molecules in a closed container at room temperature, which is 25 degrees Celsius. At this temperature, the water molecules exhibit as liquid phase. At higher temperature, the kinetic energy of the water molecules increases and the molecules will move faster. More molecules will have enough kinetic energy to overcome the intermolecular forces between them, and it will escape as vapor in the gas phase. Evaporation is also a process in which a liquid is changed into gas, but the difference is evaporation can occur at any time, but the vaporization will occur only when the liquid boils. We know that particles in liquid move quite freely in a constant motion, but these particles do not possess the same amount of kinetic energy. The particles at the surface gain enough kinetic energy to overcome the intermolecular or attractive force that bind them within the liquid. These particles will escape as vapor in the gas phase. There are three factors that will affect the rates of vaporization or the evaporation. The first one is the surface area. The larger the surface area, the higher the chances for the particles to escape from the surface. Thus, the rate of vaporization or evaporation will increase. That's why we are able to sip the hot drinks from a saucer faster than from a cup. This is because the surface area of the saucer is bigger than the surface area of a cup. The second factor is the intermolecular forces between the molecules. The weaker the intermolecular forces between the molecules, the higher the rate of vaporization or evaporation. If we put a drop of water and a drop of acetone on the different swatch glass, we can see that acetone will vaporize faster than water. This is because water has hydrogen bond between its molecules while acetone only has a dipole-dipole force. Hydrogen bond is stronger than the dipole-dipole force. That's why the molecules in water are bind together strongly compared to molecules in acetone. Another factor that will affect the rate of vaporization or the evaporation is temperature. As the temperature increases, the total number of particles with high kinetic energy increases. The frequency of the collision between the particles will also increases, and more particles will have enough kinetic energy to escape from the surface of liquid. Thus, the rate of vaporization or evaporation increases. If you look at this diagram, we have two different conditions of the temperature, where the T1 is less than the T2. So the temperature of the T2 is higher than the temperature of the T1. The vapor particles at T1 is less than the vapor particles at T2. Thus, the rate of vaporization at T2 is higher than the rate of vaporization at T1. Why do we feel cold when we sweat? Actually, evaporation is why sweating cools us down. The liquid sweat absorbs energy from our skin so that it can evaporate. This will cool our skin. Actually, our body uses this mechanism to maintain our body at the optimum temperature. The evaporation is also the reason why our damp clothes dry on a washing line. The water particles are rapidly moved away from the washing after they have escaped. If you want your clothes dry faster, you have to spread it out so that the surface area is larger. The larger the surface area, the higher the rate of evaporation. Also, in a sunny day, our clothes will dry faster. This is because at higher temperature, rate of evaporation is increased. Condensation is a process in which a gas is changed into liquid. Actually, condensation is an opposite of evaporation. When a gas is cooled to a very low temperature, the particles of the gas will move slowly. So these particles are close to one another and able to attract one another and begin to form a liquid. Everyone have observed that when we have a cool water in a glass, some water droplets will accumulate on the outside of the glass. Did the droplets come pass through the glass? Well, it didn't. As the glass becomes cool from the ice in the water, actually it will reach a temperature where the condensation happens at a higher rate than evaporation. When the hot air comes in contact with the cold glass, the heat is transferred from the hot air to the cold glass. The loss of heat in the surrounding air causes the water vapor by the glass to lose energy. Once the energy is lost, the particles will move slowly and become closer to each other. The water vapor will condense into liquid on the glass.